Hello everyone. In this video, we will find the inverse Laplace transform of function fs. Given function fs equal to 4 minus 9s divided by s minus 5 multiplied by s squared plus 7. Note that we have two factors as the denominators. So in this case, it's obviously that we have to use partial fraction method. Note that s minus 5 is the non-repeated linear factor. As a reminder, linear factor is when you have s raised to exponent 1. The second factor is the non-repeated quadratic factor. Note that quadratic factors is when you have x raised to the exponent 2. Then we have two factors in this case as the denominators. Then what you do is you must break this into two fraction decompositions. One of the denominator will be s minus 5. The other denominator is s squared plus 7. So what do we need to write as the numerators here? Okay, so remember this. If we have a non-repeated linear factors, then I must have the fraction in this form. I should have just the constant a as the numerators. If I have a non-repeated quadratic factors, then my numerators must have two variables. So in this case, I already use a, so I will write b s plus c. Alright, so let's rewrite this statement again. I should have 4 minus 9s divided by s minus 5 multiplied by s squared plus 7 equal to a divided by s minus 5 plus bs plus c divided by s squared plus 7. Okay, at this point, what we can do is we can skip the in-between algebraic step and we can write our statement as 4 minus 9s equal to a times s squared plus 7 plus s minus 5 multiplied by bs plus c. Okay, so I believe that everyone already know how to come to this step. Okay, so I will skip all the little step in between and I just want to write the statement 4 minus 9s equal to a multiplied by s squared plus 7, and I can write s minus 5 multiplied by bs plus c. At this point, I would like you to notice that if I let s equal to 5, this term will be 0. So with the term equal to 0, I can easily solve for a. So I can have 4 minus 9s equal to a s squared plus 7, but I will let s equal to 5. Therefore, I can replace this by 5. Okay, so I can write 5 here, multiplied by 5, and here is 5 squared. So on this side of the equation, I should have 4 minus 45 equal to a, and inside the bracket, I should have 32. So negative 41 equal to 32a. Therefore, a should be equal to negative 41 divided by 32. So let's circle this. Make sure that we note that we've already found a. Okay, so let's go back to our equations. Alright, okay, go back to this equation that we have. So in this equation, if I let s equal to 5, I can solve for a. But now the next step is to solve for b and solve for c. And according to this, I cannot let s equal to anything in order to substitute in here in this statement to eliminate this term. So we have to use the method called equating the coefficients. Okay? Equating the coefficient. Equating the coefficient, I would like to rewrite what I have. 4 minus 9s equal to a times s squared plus 7 plus s minus 5 multiplied by bs plus c. What I have to do is I need to multiply a inside the bracket. So I must expand all of this term. Then I should have as squared plus 7a plus bs squared plus cs minus 5 times bs minus 5 times c. And then my next step is to write this side by side. I write as squared plus bs squared. Notice that you have the same variables here, s squared and s squared. Okay, the next one I will write is plus cs subtract 5 times bs. Note that I have the same variable as s. So I will group the 7a minus 5c as my last two terms. So let's write what we have on this side, 4 minus 9s. Okay, so now the next step is I will factor s squared out because I have the common factor as s squared. So I will write a plus b in the bracket times s squared. Okay, the next step is I will factor out the s, and inside the bracket I should have c minus 5b. And I put this in the bracket. Okay, so now we are ready to perform the step called equating the coefficient. Equating the coefficient, you want to write 0s squared on this side of the equation minus 9s plus 4. Because what you have on this side of the equation is you have the variable s squared, you have the variable s, and here you don't have any variable or s to the exponent 0. I should say that. But here you have s squared, now you have s, and here you don't have any s. So you can equate the coefficient by, for this statement to be true, then you should have a plus b equal to 0. Okay, so let's circle that. A plus b has to be equal to 0 for it to be true. The next step is c minus 5b. Recognize that it's actually equal to minus 9. Okay, for this to be true, then I should have negative 9 equal to c minus 5b. And in the end, I should have 7a minus 5c equals to 4. So now you see that you have 3 equations and 3 unknown to solve. So let's call this equation number 1, equation number 2, and here's our equation number 3. In order to solve for 3 unknowns, you need at least 3 equations. So in this case, don't forget that we already found a equal to negative 41 over 32, as we found that earlier up here. Okay, so what I will do is I will substitute a into equation number 1. Substitute a equals to minus 41 divided by 32 into equation number 1. I can solve for b. So I have negative 41 over 32 plus b equal to 0. Therefore, b is equal to 41 over 32. So we can also circle this, and we already saw for a equal to negative 41 over 32 and b equals to 41 over 32. So the next step is to solve for c. Okay, so from equation number 2, okay, you can solve for c by putting 5 multiplied by 41 over 32 equal to negative 9. So then c will be equal to negative 9 add 5 times 41 over 32. So let's find out what c equal to. C equal to negative 9 plus 205 divided by 32. So in this case, I should have negative 288 divided by 32 plus 205 divided by 32. So c is equal to negative 83 over 32. Okay, so let's circle that. So we found A, found B, and found C. So at this point, you probably ask me, so why do you need these equations? So this equation is very useful in the way that you can substitute the value of A and C into equation 3 to see if you actually found the correct solution for A, B, and C. So I would say we use equation 3 to test our answer. Okay, use 3 to test the answer. Alright, okay, so in equation 3, what I have is seven a minus 5c equal to 4. Okay, so I have 7a minus 5c equals to 4. So what I have is 7 times negative 41 over 32 subtract 5 times c. I just found that as negative 83 over 32. Let's see if this is equal to 4. Okay, so in this case I will have negative 287 over 32 plus 415 over 32. Let's say is equal to 5. So I can have negative 287 plus 415 over 35 equal to 4. So this should be 128 over 32 equal to 4. So 4 is equal to 4. So I got all the 3 values correct. So let's write it down. Okay, so write down our A, our B, and our C. So A equals to negative 41 over 32. B equal to 41 over 32. And C equal to negative 83 over 32. Okay, so the next step is to substitute these 3 values into our function fs. So fs at this point will be equal to negative 41 over 32, the whole thing divided by s minus 5. And add that with 41 over 32, s subtract 83 over 32, all of this divided by s squared plus 7. Alright, okay. So I would like you to notice this. Okay, it's the very first fraction that we have. What we do is we will factor out 41 over 32. Inside the bracket, I have it 1 over s minus 5. The reason I'm doing this is because I would like you to recognize what transform that you need to use for this particular fraction. So let's go to our Laplace transform table. On the Laplace transform table, you see that you have 1 over s plus 8. So therefore, you are going to use transform number 3. Okay, so I will write down transform number 3. And in this case, a is equal to minus 5. So let's leave that. And the next step is I need to break this into 2. So this one, I need to break that into 2 fractions. Okay, so let's write down the 2 fractions that we have. 41 over 32s divided by s squared plus 7. Add that with, add that with negative of 83 over 32 over s squared plus 7. Okay, so at this point what you do is you can write this as subtract, okay, 83 over 32 as the denominators, as the numerator, and then divided by s squared plus 7. Alright, so let's go to our Laplace transform table and find what transform that we need to use for this one right here. Okay, so let's go to our Laplace transform table, and we are going to look for the one that's similar to that. So let's go here, and what I have is alright, okay, so I have s on top, I have s squared, and I have a squared. So I should use transform number 5. Okay. So I'm going to write down that I'm going to use transform number 5. Okay. So with transform number 5, I should have this as a square. But I only have 7. To turn that into a square, I can write square root of 7 square, right? So I can put it here as square root of 7 square. So in this case, a is equal to root of 7. So here I have s, but I don't need 41 over 32. So in this case, what you can do is you can pull the 41 over 32 outside the brackets, and in here you should have s left, and you have s squared plus root 7 squared. Alright, so let's write our first fraction again. Okay, so the next step I would like you to look at is to examine this one right here. Okay, so note that you don't have s as the numerators. So what's transform that I just have a number, and then here's the s squared as the denominators. So let's go to our Laplace transform table. So on this Laplace transform table, I noticed that I have a, here's a squared, I have s squared, so I'm going to use transform number 6. Okay, so let's write out transform number 6. So transform number 6. Okay, transform number 6 said that I should have a over s squared plus a squared. Okay, so a squared in this case should be root 7 squared. So I will write s squared plus root 7 squared. And on top, I should have a. So right here, I should have root 7. Okay. And at the same time, I want to write 83 over 32 outside this bracket. Here you multiply by root 7. Therefore, you have to divide it by root 7. Okay. So with using transform number 6, I should have a equal to root 7. So let's check that. So a equal to root 7. So here I have root 7. A square, I have a square. Root 7 square, I have s square. And multiply by root 7, I have to divide it by root 7. And I pull 83 over 32 outside the brackets. So we are almost get to what we need to write Laplace inverse of fs. So now I'm going to transform this into a function in terms of time. Alright, okay. So let's write that down. I will have negative 41 over 32. Transform number 5. I should write e to the negative 80. So it's negative of negative 5. So I should have 5 times t. The next one is adding 41 over 32. And I write cos of root 7t. And this one I should have subtract 83 over 32 times root 7, because you need to multiply these two. And inside this, I should write sine of root 7t. Okay, so let's simplify our answer. To simplify our answer, you can factor out the 1 or the 32. However, here's what I have. As rationalize the denominators, okay, rationalize the denominators, you need to multiply root 7 on top and root 7 at the bottom as well. Okay, so in this case, I will have 83 times root 7 divided by root 7 times root 7 is 7. 32 times 7 will be 224. Okay, so sine of root 7t. And at this point, if you factor out 1 over 32, inside the brackets you left with negative 41 e to the exponent 5t at 41 times cos of root 7t. And in here you should have, because you take out the 32, so you have 7 left. So 83 root 7 over 7 sine root 7t as the argument. So let's double check our answer. So I should have negative 41 over 32 e to the exponent 5t, 41 over 32 cos of root 7t, and this as rationalize the denominators, multiply by sine of root 7t. If you factor out 1 over 32, you left with negative 41 times e to the exponent 5t. This term you should have 41 times cos of root 7t, and take out 1 over 32, you should have 83 times root 7 over 7 times sine of root 7t in the brackets as the argument. Okay, and we are done. Thank you.